Welcome. I am sad to say that the grand solar minimum hypothesis is on life support, and the prognosis does not look very good. What is a grand solar minimum? A grand solar minimum occurs when several successive solar cycles exhibit lesser than average activity for decades or centuries. But this definition is a little bit vague because it doesn't say how many several is. The dictionary defines several as 3 or more. We can use statistics to see what several means, and in my case I believe it means statistically meaningful. If we're looking for below average as opposed to above average cycles, then it's rather like a coin toss. There's a 50-50 chance of it being above average or below average. We can model that mathematically by calculating the probability for successive numbers of consecutive heads, for example, or tails. So to get one head, it's a 50-50 chance, either heads or tails. To get 2, it's a 25% chance. To get 3, it's a 12.5% chance, and so on. And this curve on the right here shows that mathematically. Now note it is a logarithmic scale. So the more consecutive heads you require, the lower the probability. Now we can do the same thing effectively for above and below average solar cycles. Now for significance in probability theory, 3 sigma is usually the criterion that we use, and that's about 1%. So that would put you there. However, that would require 6 consecutive heads or 6 consecutive below average solar cycles to say it's meaningful. So you'd say that that's a little bit of a tough criterion. So let's go back to 2 sigma, and that would require 4 consecutive below average minima before we can call it significant. Well, how do the solar minima that we have so far compare? Certainly, there's your 4-cycle criterion, so anything longer than that could be considered a grand solar minimum. So certainly the Maunder minimum qualifies. The Dalton minimum doesn't because it's just got 2, nor does the minimum at the beginning of the 19th century. Certainly the current one doesn't because we've only had 1 below average cycle so far. So from that point of view, we have only 1 example of a grand solar minimum in our record books. When you look at the Maunder minimum in detail, you find that it's fundamentally different from the other low activity periods like the Dalton minimum. The Maunder minimum is long. It's 7 cycles long, whereas these other periods are just 1 or 2 cycles long. This is about the average for the Dalton minimum. And you can see that the Maunder minimum is at least a factor of 10 lower than the Dalton minimum. So we can conclude that the Maunder minimum is 3 times longer than any of these other cycles and a factor of 10 lower. So this is a fundamentally different period of solar activity than the Dalton minimum or the minimum at the beginning of the 19th century. So what are the symptoms of a grand solar minimum? Well, obviously very low sunspot numbers for at least 40 years. Very few flares or no flares at all. With weak sunspots, you're not going to get very many flares. Few CMEs. Now, CMEs can be associated with flares, but they're also associated with filament eruptions, which still go on at solar minimum. That will produce few, if any, geomagnetic storms during that period. And with exceptional solar minimum conditions going on for decades. So this is what we're looking for to prove that we're in a grand solar minimum. Does the modern period qualify? So the first question is, are we entering or have we entered a grand solar minimum? Let's take a more detailed look at the Maunder minimum and see its characteristics. There is absolutely no evidence that we're going into a similar situation as the Maunder minimum. If you look at the sunspot numbers, the onset of the Maunder minimum was quite sudden. We had a perfectly normal solar cycle just prior to the onset of the Maunder minimum, and then basically the bottom fell out of the sunspot market. We also had a fast exit from the Maunder minimum. It jumped from very low sunspot numbers to a moderate to average sunspot number in just 1 cycle. The fact is that solar minima occur every 11 years. So is the current solar minimum that we've just come through different in any way from previous ones that would make us suspect that we're going into a Maunder minimum? And the answer to that seems to be no. Here is the sunspot number over the last 13 years, showing the most recent minimum. This is the sort of level where you would, below which you would call the sunspot number in a solar minimum condition. And so that's the length and size of your Maunder minimum. It's about 2.5 years. Well, let's take a look at the previous cycle, and the minimum there, on exactly the same scale, is almost identical. So last time we had a solar minimum similar to the one we've just had, and it didn't produce a grand solar minimum. So why is there any suspicion that the current one will? The answer to that is there isn't any. Some people argue that the sun is cooling down. Unfortunately for them, it isn't. This is the total solar irradiance coming from the sun, the amount of energy coming from the sun. And look at the solar minimum that we just went through, and you can see that it is low, but it's not as low as the previous one. In fact, there's a general increase in solar irradiance during that time. So you could say that the sun is actually warming up, if anything. Also note the scale of this variation in total solar irradiance. It's about 0.1 watts per meter squared. And let's put that in perspective. When you compare that with the forcing from carbon dioxide and other greenhouse gases in the atmosphere, this is only 4% of what they are producing. So this is negligible in comparison. Some people like to make a huge fuss about the number of spotless days as an indicator of what the cycle is going to do or is doing. I don't give it very much credibility, but for completeness, I'll include it anyway. This is a plot of the percentage of days in each month since the beginning of solar cycle 25 that were spotless. Now, the minimum between solar cycle 24 and 25 was December of 2019, so the cycle began in January of 2020. And you can see here that initially there were a large number of spotless days, sometimes in the high 90s of spotless days in the first few months. But this is exponentially decayed, and recently, the last 2 months, we've had no spotless days at all. In fact, it's been 52 days since the last spotless day on the sun, and it looks as though it's going to go quite a long time before there are any more of them. In the same period, for solar cycle 24, there were 307 compared with 242 in solar cycle 25. So solar cycle 25 has 21% fewer spotless days than solar cycle 24. So if you give any of this spotless day stuff credibility, then you'd have to say that solar cycle 25 is far more active than solar cycle 24. Some people like to quote weird weather as evidence for a grand solar minimum. Floods, droughts, cold snaps, volcanic eruptions, crop losses, all attributed to the grand solar minimum. The only problem is, how can these effects be happening before the grand solar minimum has started? We've shown that we aren't in a grand solar minimum yet. In fact, the sun, if anything, is getting slightly more active. Yet they are attributing all these strange things that are going on in the weather to the grand solar minimum, rather than the changes in climate caused by excess greenhouse gases and aerosols in our atmosphere. When doing predictions in science, we deal in probabilities, and this is a probability plot from NASA showing what they think the next cycle will be like. The green curve here, the 50 percentile curve, is the best guess at their model. That says, of all the possible solutions, about 50% of them will fall above this line, and about 50% of them will fall below this line. That's the coin toss I was talking about previously. Now we can take a look at other things here. The red line, for example, is the 5 percentile line, which says that 95% of all the other results will lie above that line. So you've only got a 1 in 20 chance of something falling below that line. Similarly, the blue line is the 95 percentile thing, which says of all the possible outcomes for this cycle, 95% of them will fall below that line. So this is sort of two bound, the blue and the red line are bounding options for the cycle. Now at the moment we are here, and that's very close to the green line, which is quite reassuring. But you'll notice that the green line peaks at 140 sunspot number, And that is actually up from 115, which was NASA's original projection. And so they've already increased the peak value of solar cycle 25. Now, most of the people that are suggesting that we're into a grand solar minimum says that the maximum of this cycle will be 80 or below. So it's very much below the red line. So they've only got a 1 in 20 chance at the moment of being right, according to this NASA model, which is not very good odds, which is why I say it's on life support. Now, you'll recall from about 2 years ago, I started making projections of this solar cycle, and this is what I was saying that the cycle would be like, about 165 plus or minus 30. And so that's not looking too bad at the moment. In fact, I've actually been tempted to up that to something like about 180, but I'm going to stick with my original guns and see what comes what may. I'm actually more concerned about the timing of the cycle than I am about the size of the cycle at the moment. So what conclusions can we draw from all of this? There we have no extremely low sunspot numbers at the moment. In fact, we have higher than average. No extended period without spots. No sudden drop in sunspot numbers after the previous cycle. So sunspot cycle 25 looks perfectly normal so far. In fact, it may even be more active than the previous cycle, so solar cycle 24. According to the NASA model, it's just as likely to be the grand solar maximum as it is to be a grand solar minimum. So all in all, one can conclude that the grand solar minimum hype has been cancelled. Until next time, stay safe and goodbye.